This is Conic Section Notes, Day 2. Today we're going to cover ellipses and hyperbolas. This first video is going to be about the ellipses. Ellipses is plural for ellipse. This is an ellipse. It is an oval shape, but it's very specific oval shape. An ellipse is the set of every point where the distance to each focal point, and there are two of them now, have a sum of 2a. So let's talk about what that means. Let's draw our ellipse right here, and let's put in our focal points right here. Every ellipse has two focal points that are located on the major or longest axis of our ellipse. Remember that an ellipse is not round, it is oval shaped, and so it has a long axis called the major axis and a short axis called the minor axis. And our foci, plural for focus, our foci live on the major axis, okay? The other thing is that the distance from the center to the vertex right there, the distance from the center to the vertex is called A. So you can see that the distance all the way across would be 2a. The cool part is, though, that if I measured this point to this focal point and this point to this other focal point and added them together, do you see that since this is A right here and this is A, that if I double this, if I measured this piece twice, let me show you with color what I'm talking about. Here's the distance to the first focal point, right? And then here's the distance to the second focal point. Can you see that? This piece has been doubled, but this was never covered. But when you recognize that these two pieces are the same length, those together add up to 2a, which means the width along the major axis. Now, why is that important? Because in order to graph and in order to create ellipses, we have to be able to use the following equations. And we can have horizontal equations where the center is at the origin. That's this one. Notice there's nothing added to x or y. Or the center is at hk. Not the vertex this time. The hk is the center on an ellipse. And I have another equation which looks very similar, except that it's x minus h and y minus k. Just like on the parabolas, we're still subtracting h and subtracting k. H always goes with x and k always goes with y. But notice that they're divided by something. Parabolas were not divided out. These are divided and they equal 1 every time. Ellipses will always have a sum of some values that equal 1. Sum of some values and they equal 1. Okay, our horizontal ellipse is going to have a longer major axis sideways, and that's why we call it horizontal. Our vertical equations are a little different. Look at the difference between the two. We have x squared over a squared plus y squared over b squared. This one is x squared over b squared equals y squared over a squared. So we have to notice the a and the b change places. The x and y did not. But the A and the B change places because A is still the distance to the vertex. And A is greater than B. So the major, A is always on the major axis. This is going to be on the vertical, right? We've got a vertical. So our distance, our A distance is vertical. On this one, our A distance is horizontal. That's why we have a horizontal equation and a vertical equation. Okay? Now, A tells us the distance to the vertex. What does B tell us? Well, B actually tells us the distance to the co-vertex. We're not going to ask you to find co-vertices, but you have to know that what B is going to tell me is the length of the minor axis. If the major axis is 2A, the minor axis is 2B. In this case, the major axis is 2A, the minor axis is 2B. And the major axis and minor axis are always perpendicular to each other. How do we find where the foci exist? There's our word foci, which is plural for focus. We find the C value by using something very similar, but we're changing something. It looks like a squared plus b squared equals c squared, but notice the difference right there. On an ellipse, which is a sum problem, we find C by subtracting. So we would do A squared minus B squared, A is always bigger than B, equals C squared. Well, that makes sense too, because C has to be smaller now. In our triangle, C was the longest side, but C is the distance to the focus from the center. And so C has to be shorter than A because you don't travel all the way to the edge of your ellipse. The vertices of the ellipse lie on the major axis A units away from the center. The foci also lie on the major axis C units away from the center. So the vertex is found from A, the foci are found from C. Ellipses do have directrices, but we are not going to discuss them, and we're not going to expect you to find them in this unit. So let's take a look at how a problem might look. I have an equation for an ellipse, okay? I know that it's an ellipse because it says plus and it equals 1. I also know that it's an ellipse because my A and B are different. That's gonna come up later. We'll talk about that in class probably, about how if they're the same, it's not an ellipse, it's a circle, but don't worry about that right now today. We have different values, and we have 25 and 16. What's the square root of 25? 5. What's the square root of 16? 4. Which one's bigger? A is always the biggest number, so my A value is 5. That's the square root of 25. Since my A value is right here under the X, let's look at our equations. Since the A value is under the X, this is a horizontal ellipse. My B value is 4. Where is my center? Well, we have x squared plus y squared. There's nothing added or subtracted. So my center is at 0, 0. What is my C value? Well, I'm going to find the C value by doing A squared minus B squared equals C squared. So 25 minus 16 equals C squared. 9 equals C squared, so 3 is C. My C value is 3. So let's start graphing this. We've got a center at 0, 0. Our major axis is horizontal, so my A value is 5 to the right and 5 to the left. There's a part of my ellipse, but I need the B value to find how tall my ellipse is. It's 4 units up, and I don't put a dot because I really don't call that a vertex, it's a co-vertex. These are actually vertices. We've got vertex, I call this vertex 1 because it's positive, and this vertex 2. It doesn't matter which one you call vertex 1 or vertex 2. Then our other B value is 4 units down. Okay, so I have vertices on the major axis, and I have my co-vertices on the minor axis. Now it looks like they're the same distance, but notice this is at 5 and this is at 4. So it's actually longer than it is tall. But we're still going to try and curve this into a nice curved shape. We don't want a diamond shape. I'm not going to grade you on your curve, okay? But I do want you to try and make it a nice ovally shape. And you'll notice that it is definitely wider than it is tall. But I also need you to label all key points. Well, we've got the vertices labeled. Let's label our foci. And the foci are going to be 1, 2, 3 to the right. There's focus 1. And 1, 2, 3 to the left. There's focus 2. So where are my vertices? Where do they exist? Well, this one is at 5, 0. And this one is at negative 5, 0. How far away are they from the center? They are 5 units from the X value of the center. Where are my focal points? Well, there are 3 values. There are 3 units on the X value away from the center. So they're going to be found at 3, 0 and negative 3, 0. If these are the same, just opposite numbers, you can rewrite that as plus or minus 3, 0, plus or minus 5, 0. You're more than welcome to do that if you don't want to write out the 2 points separately. Okay, let's take a look at the next problem. Our next problem, once again, we know it's an ellipse. We have movement now. We have -3 and +1, so we know that our HK are actually found at 3, -1. So my center is at 3, -1. So I'm going to go 1, 2, 3, down 1, and there's my center. Now we have to look. I have two numbers. The bigger one is here. It's under the X. So this is once again a horizontal ellipse. My A value is the square root of 9. My B value is the square root of 4. I need to find my C value. So I'm going to come down here and I'm going to write A squared minus B squared equals C squared. So 5 equals C squared, which means that C is the square root of 5. So my C value is the square root of 5. Now I put that in my calculator and I know that that is approximately 2.2. 2.2 units. Okay. Now, let's graph. It's horizontal, so I'm going to go 3 units to the right, 3 units to the left, and there are my vertices, vertex 1 and vertex 2. Where are they located? 6, -1, and 0, -1. Notice, 3 units from the X to the right, 3 units from the X to the left, and that's a +3. I don't want you to think I had a negative there, okay? Where my B value is 2, so I'm going to go up 2 from the center. From the center. There's my up 2. There's my down 2. And I'm going to kind of curve this thing out and make it almost egg-shaped, a nice elliptical shape. Okay? And the section of the cone that the ellipse is crossing through both sides of the cone. Like here's my cone right here. It crosses through both sides of the cone, my slice, but it's not flat either. Remember, the circle was perpendicular. The parabola went through only one side of the cone. This goes through both sides of the cone, but it's not flat. It's not perpendicular to the center. And that's why it's got a longer shape on one axis than on the other. So where are my foci? Well, my foci are √5 away from the center. On which axis? The horizontal. So it's going to affect the X value. So my foci are found at 3 plus √5, -1, and 3 minus √5, -1. Now, when I graph those, how do I know where plus √5 and minus √5 is? Remember, C was approximately 2.2. So I'm going to go 1, 2, and a tiny little bit, and there's focus 1, 1, 2, and a tiny little bit, and there's focus 2. We've now labeled all of our key points. We know we have a horizontal ellipse, and we have found the locations that are needed. Our next problem is different still. It looks very similar, so be very careful with this one. When you look at this problem, I hope that you notice that once again the center is offset. Our center is at -2, 1, so our HK is -2, 1. That's the center of our vertex, -2, 1. There's a 4 here and a 9 here. The bigger value is under the Y. So when you go back and you look at your equations, when the bigger value is under the Y, we have a vertical. This is on the major axis, and we have a vertical equation. So our A value is not under the X this time. Our A value is right here because our major axis through this center point is going to be vertical. So this is a vertical ellipse. Our A value is 3. It's the square root of the larger number. Our B value is 2. We take 9 minus 4. A squared minus B squared equals C squared. 5 is C squared again, so the square root of 5 equals C, and we know that's approximately 2.2 units. Okay, our C value right here Where are my vertices? Well, this time we're going to go vertically 3 units. So we're going to go 1, 2, 3 units up, 1, 2, 3 units, 1, 2, 3 units down. There is vertex 1 and vertex 2. Where are they located? -2, 4. -2, 4, which you'll notice is 3 units above the y value. And -2, -1. I'm sorry, -2, -2, which is 3 units below the center y value. 3 above, 3 below. Where are my focal points? My focal points are going to be √5 away from the y value this time. So -2, 1 plus √5 and -2, 1 minus √5. Now, that means that we're going to go up 2.2. There's my focal point 1. Go down 2 and a little bit. There's my focal point 2. Now, I still don't have my width. Remember, the major axis tells me how long it is. The b value tells me how far to go in the perpendicular direction, 2 to the right, 2 to the left, and I'm going to kind of nicely turn that into an elliptical shape, kind of round it on the edges. Let's try not to make it a diamond, okay? So our last problem on this video is when we're given information and they want an equation, okay? So it says we've been given the vertices are at -3, 2, and 5, 2. And one focal point is at -1, +2. And they want us to write an equation for the ellipse, but there's a hint. Find the center of the ellipse first. The center of the ellipse is halfway in between either the 2 focal points, if we had 2 of those, or the 2 vertices. I have 2 vertices, so let's list them. We've got -3, 2, and +5, 2. That's on the major axis. Remember, the vertices are on the major axis. That means this is horizontal. So I'm going to find the center, halfway in between. This is 1, 2, 3, 4, 5, 6, 7, 8 units. So halfway is right there at 1, 2. So my center, my HK, is at 1, 2. Vertex 1, vertex 2, vertex 1, vertex 2, I don't care which way you label them. And I have a focal point at -1, 2. There's a focal point. See the major axis going on there? Where is my other focal point? If this is 2 units to the left, my other focal point is 2 units to the right. So we have focal point 1 and focal point 2. You can switch the letters, I don't care. That means I know some information. I know that A is the distance from the center. So here's A. 1, 2, 3, 4. A is 4. I also know that C is the distance to the focus from the center. So my C value is 2. What I don't know is my B value. But I can use the equation A squared minus B squared equals C squared. -B squared equals -12. I'm going to subtract 16 from both sides. Divide by negative, so I can take the square root. And B is actually equal to the square root of 12. And the square root of 12 is 2√3. And it's approximately 3.5 units. Okay? So my A value is 4. My B value is 2√3, or you could say, you could leave it as the square root of 12. That's fine. Or you could say it's approximately 3.5. Okay. So I have to go up from the center 3.5 units, down from the center 1, 2, 3.5, 1, 2, 3.5 units, and I can curve my ellipse, and I know what I'm looking at, right? The problem is it almost looks circular because that's really close. 4 and 3.5, that's really almost circular. That's almost equal. But I still don't have an equation. Well, we know we need the horizontal pattern, which is, and because HK is not at 0, it's going to be X minus H all squared plus Y minus K all squared over, and remember this is horizontal, so the bigger one is under the x and the smaller one is under the y, and that's going to equal 1. So let's start plugging in. X minus 1 all squared over 4 squared, which is 16, plus y minus 2, there's my k value, all squared, over 2 root 3 squared. Well, what is that? Well, remember, b squared was 12, so that equals 12. And that equals 1, and there's the equation of our ellipse.